get informed and cut through the hype, this is the place for you. This video covers the concept of the transformer, the underpinning technology behind the explosive development of large language models, LLMs, like Gemini, ChatGPT, Claude, and Grok. It will explain what they are and their limitations. To understand why the transformer has been revolutionary, you first need to understand the world before it. For years, AI tools that worked with language, like Google Translate, were based on something called recurrent neural networks, or RNNs. An RNN reads a sentence one word at a time, from left to right, forming a little memory of it, then moving on to the next word. The problem was that RNN's memory was terrible. By the time it got to the end of a long paragraph, it had all but forgotten the beginning. RNNs just couldn't connect the dots over long distances, and the one word at a time process was incredibly slow. Then, in 2017, a team at Google published a revolutionary paper titled "Attention is All You Need." They proposed a radical new architecture called the transformer to get rid of the sequential word-by-word process entirely. The transformer could look at an entire sentence all at once using a process called self-attention, which looks at every single word in a sentence and asks, which other words in this entire text are most important to understanding me? It then creates weighted connections between words, no matter how far apart they are. The subject at the start of a paragraph can now be directly linked to a pronoun at the very end. The context is no longer lost. And they didn't stop there. Instead of having the model pay attention in just one way, they gave it something called multi-head attention. You can picture this as having multiple sets of eyes looking at the sentence simultaneously. One set might be tracking grammatical relationships, another might be tracking who did what to whom, and a third might track the overall sentiment. All of this happens in parallel, which means you can throw massive amounts of computing power at it, training models on a scale that was simply impossible before. You can also keep adding more layers and more attention heads to build bigger and more powerful models. These scalability features are the direct cause of the LLM revolution we see today. But as with any powerful technology, there's a flip side. The advantages of the transformer come with some downsides too. The most obvious downside is the enormous computational and energy cost. Training a state-of-the-art LLM can cost hundreds of millions of dollars because it has to be shown so much data to learn how language works. This creates a high barrier to entry and has a big environmental footprint. Related to this is something called quadratic complexity. In simple terms, the longer the text you give the model, the computational cost doesn't just increase, it explodes. This is why most AI models have a limited context window for the amount of text they can handle. They're still not great at, say, reading an entire novel in one go. Finally, and perhaps most importantly, is the black box problem. LLMs based on transformers with billions of parameters are so complex that even their creators don't fully understand why they give a specific answer. This raises profound questions about safety, trust, and legal responsibility. If an AI makes a critical decision, but we can't understand why, can we ever truly rely on it? Overall, the transformer architecture has been a paradigm-shifting development that has unlocked our current AI moment. But it also introduced challenges of cost and interpretability that researchers are now working desperately to solve.